Hi everyone and welcome to Kubernetes Health Management with Komodor. Today we're going to break down the concept of Kubernetes Health and what it even means to manage Kubernetes Health. And then we will show how we do it at Komodor. And there's no better person to walk us through this topic than Daniel Bar. And so welcome Daniel Bar, Director of Product Management at Komodor. And please introduce yourself and tell us about today's session.
Okay, so hi everyone, happy to be here. I'm Danielle, I'm a product director at Komodor. I previously worked at Snyk, specifically on the Snyk container product and later on the legacy Snyk open source products. I've spent a couple of years at Spot.io, which was acquired by NetApp as a product manager in the areas of cost optimization in the cloud and specifically in Kubernetes. And if we go way back, I was also a software engineer at Motorola and QA at Verint. I'm also a mother of Arbel and Yuval and the sweet dog Charlie, who is the office star.
Indeed. So, Daniel, tell us what are your thoughts about Kubernetes observability? Where is the state of observability now, and why do people say that observability is broken? What's inadequate about the traditional monitoring solutions that doesn't work in the Kubernetes era?
So we all know Kubernetes is really hard and is complex. So it's not only us that are talking about this complexity. And it's worth mentioning that even Tim Hawking, the co-founder of Kubernetes, is saying that this complexity of Kubernetes is only getting worse as it gets more and more complicated because organizations are actually not being able to move forward and to release features because they need to spend more and more time in Kubernetes. So the complexity is basically a tax that we need to pay on innovation, on velocity, and on scale. So if engineers are too busy in firefighting or serving as a Kubernetes help desk, it basically means that they're not busy in building new features, in innovating and improving their own products.
It's kind of like a double-edged sword, right? So as Kubernetes becomes more robust and has more capabilities and it's becoming more ubiquitous, the more complicated it gets. So you can't have it both ways. You get all the capabilities, but you also get this tax that you mentioned that you need to maintain Kubernetes. And some organizations have whole teams just to maintain Kubernetes.
Yeah, exactly that. And just to say that up until now, not too long ago, most of the organizations had like only two layers that they had in mind and needed to take care of. So they had the application layer and they had the infrastructure layer. And those organizations, on the one hand, spend a lot of time and resources and tools and money eventually in order to come up with monitoring tools for each one of the layers. So for applications, you had APM tools, such as Datadog, for example. And for infrastructure, you had different infrastructure monitoring solutions. So that's on the one hand that you need to pay all of that money and resources. But on the other hand, you only had two layers to take care of. And when we talk about today, Kubernetes came along and it's very unique because it has one leg in the application layer and the other leg is in the infrastructure layer. And Kubernetes sits somewhere in between those two. So under the application layer of Kubernetes, you have the classic Kubernetes workload. So you have the pods, deployments, jobs, stateful sets. But Kubernetes has even more layers. So you have the configuration layer that holds all the networking and storage and access and control and a whole universe basically that is attached to it. You have the add-ons layer, so it's all of the CRDs and operators. Things like Cert Manager, external DNS, autoscalers, and so on. And you also have like the cloud provider themselves. So you have the nodes, the control plane, all the different Kubernetes distros, and it basically, this is what also composes the new Kubernetes layer. So you have a lot of elements that combined to that Kubernetes cluster. And that complexity basically brings something that is very new and very overwhelming for most organizations. And the problem is that once you try to scale, once you go and have dozens or even hundreds of clusters, especially if you're using multi-cloud or hybrid cloud approaches, that becomes much more complex. And this complexity just exponentially grows, and it gets harder and very difficult and time consuming to basically operate and manage Kubernetes. So in order to, I would say, tame that Kubernetes chaos, you need to invest a lot of time and resources.
Yeah, and we can see here that you have different regions, different distros, cloud providers, some are on-prem, some are edge, and it's all part of the same organization, same infrastructure.
Yeah. And if something is not done properly, like if you make even the slightest mistake in configuration, in whatever, you can reach to a situation where you start to see a lot of issues and a lot of incidents, and things like pods that are restarting, jobs that are not functioning as expected, nodes with high pressure, and so on. So the bottom line is that managing this entire health of Kubernetes is really hard to do on your own.
So what is Kubernetes health? You said it's something that's hard to manage due to all the complexity and scale of Kubernetes and the sheer volume of data that's being generated. But what is Kubernetes health?
So I think in order to start talking about Kubernetes health, we first need to understand the complexity of it and maybe realize a little bit how it has changed over the years. So Kubernetes is not only pods and deployments and pods that we all know, and it's much more than that. And a lot of it are things that are actually going on like under the surface, and we're not really exposed to them, and we don't really have good visibility into them. And it feels like the deeper you go, the more complex things are getting. Like if you think about it, Kubernetes is sort of the operating system of the cloud. It's like a platform that you run other platforms on top of it. And we're most of the time are only focused on the tip of the iceberg, let's call it. And we actually forget about everything that lies underneath. And that poses a lot of challenges in Kubernetes that make it really hard to manage. And if we're talking about challenges, you can see here a very short list of things that Kubernetes makes it hard to do. So first of all, you have the operational toil. So as we talked until now, Kubernetes is complex. And needing to run production clusters at scale is very scary, but also requires hard work and maintenance. And you also have complex correlations. So within Kubernetes, you have tons of resources. Outside of Kubernetes, you have tons of tools that integrate and enrich Kubernetes. And all of those connections and correlations that need to be done is a lot for a human being to handle. You also have the risk of downtime, of course, which can be caused by any misconfiguration or delays or anything like that, and eventually leads to a very bad user experience for your users. And for everything that I've just mentioned, you also have, if you add on top of that lack of visibility and ability to be proactive, it gets even harder. And the last thing is the impact on the productivity. So if organizations are focused on firefighting, they don't really have time to focus on delivering, right? So if we dive into an example of like a modern day Kubernetes issue and see what are the best practices to address it today with the tools that are available today. So this example is for Sales Manager. For those of you who are not familiar with it, so Sales Manager is basically a Kubernetes tool that automates everything around TLS certificates within Kubernetes, of course. So it's responsible for managing, issuing, renewal of certificates, and its job is basically to make sure that you have secured communication between the applications and services in your clusters. So in this example, I have a developer who sees a web service is down. So what do? They start inspecting the Kubernetes deployment and see that all the pods are failing. They go on and inspect the logs and see that there is a failure in connecting to the database. They continue to inspect the database pods and see that everything is up and running. They then go and check the logs and they see that there are no issues. And eventually they inspect the database connections and they see that they drop to zero. So after 1 hour of downtime and a lot of frustration and time waste, they reach out to the DevOps, of course. So what does the DevOps person do? The first thing is to do all of that all over again. So they inspect everything again. After they get to exactly the same conclusion, they move on to inspecting network policies and they see that there are no issues. They move on to inspect the certificates, but they see that the certificate expired. They go on and look into the certificate to Sales Manager and to see what happened with the renewal, and it indeed failed the renewal. So they understand that there is an issuer problem. They go to the issuer and see that there was a DNS problem, and eventually they fix the DNS problem. And I need a second to breathe after all of this. But as you can see, there are 2 hours of downtime, 2 teams, like more than 10 steps of investigation, only to get to the root cause that could have been prevented or could have been found a lot quicker if there was something that automates this entire process. So in order to maintain the cluster health, you need a much better mechanism. So if you take a look at this matrix, for example, that we have here, and see how many data points you have to correlate to gain any like meaningful insights, and now think that you need to multiply that by the number of clusters that you're running, this is insane. So think of the fact that within each one of those entities, let's call it, you have tons of inner resources. So you have PVCs, you have stateful sets, you have within the CRDs, you have Carpenter, Istio, tons of resources and a lot of information. And for each one, you need to do all that mapping. And it's really hard to do that for multiple layers in order to get the bigger picture.
What is the Komodor approach? What exactly do we do different than others?
So when we say Kubernetes health management, I think that Komodor really brings a unique offering to the table. So what we do, we start by first differentiating between the infrastructure issues, between workload issues, between add-ons. For each one of those, we examine different types of issues. So we have reliability risks, we have real-time issues, we have configuration violations, we have configuration drifts. And really, each one of them is a whole world. So if we dive in a little bit into each one, the first one is reliability risks. So that's really things that are not posing an immediate issue in your cluster, but are important to pay attention to. So those are things that are ongoing and may cause something that is more concrete in your cluster. So I like to think about it as a gas leak. It's important. You should know that it's there and you should take action. Um, you have also the real time issue. So if we're talking about gas leaks, so this is really the house that is on fire and everything is burning. And in those cases, you must take action. You also have the standard violations. So Komodor checks for configuration and understand whether there is specific standards that are violated and they're not configured as per your organization's requirements or things like that. And you also have the configuration drift, which is basically to understand whether all your environments have the same configuration, or let's say your desired configuration. And basically, for each one of those resources and each one of those problems, we have a very clear and repetitive process. So we first detect that there is an issue. We then prioritize it and help you in investigating it. So we have our AI-driven root cause analysis and guided investigation that basically help you in understanding what is the root cause of things. We then help you in remediating. We have run books, we have out of the box solutions that are supposed to help you in finding the right solution for that exact problem. And eventually, we also proactively optimize your Kubernetes health, and by that, help you in preventing similar issues from happening again in the future.
So, Danielle, tell me about Komodor. So, Komodor is a whole platform. It's not just health management. So, tell me more about the full Kubernetes management platform that is Komodor.
Yeah, so until now, we talked a lot about the Kubernetes health management approach. Um, but what we have is really an entire platform that is basically supposed to automate and simplifies everything around around Kubernetes. So you have things like cost optimization, you have user management, which basically helps defining who can do what exactly and when also. So teams like data engineers, developers, NOC, SREs, all of those different teams or people eventually get their own view, get their own focus on exactly where they need to be and what they need to do. Um, and that's really one of the tools that can help you to get to Kubernetes health management in terms of being focused only on the things that are interesting for you, being focused only on the areas that you're supposed to be in, and the byproduct of that would be to improve basically the entire Kubernetes health. So if we dive a little bit into how it works exactly, so Komodor has a swarm of agents which are deployed in the Kubernetes cluster. We also have static data that we get from config maps, from liveness and readiness probes, from cluster roles and things and entities like that. And we also take runtime data. For example, from the logs of the workload that you're running, metrics, deployments, jobs, all of those. And we also use third-party tools. So if you need to enrich the data with other tools that you're already using, such as GitHub, Datadog, things like that. We also pull data from there, and we take all of that information and put it within our enrichment engine and send it back to our backend, to the brain. This is how we call it. So there we have like a loop that keeps on running, that analyzes all the history using machine learning, does all the correlations using our correlation engine, takes into consideration the Kubernetes knowledge base that we already have, and we have also a predictive model that can help us optimize future cases of things that are happening within your cluster. So once all of that is ready, if we're talking about issues, we send that to our AI engine that is called Claudia to get help in digesting all of this data into root cause analysis eventually, and by that helping us with the health and reliability management. And all the rest of the information is digested into the cost optimization pillar and the user management one, which eventually translates into workspaces, which are exactly what we talked about a few minutes ago, the areas of each user and their role and what they are supposed to handle eventually. So if we're talking about how things look with Komodor, so you can see that you started off with everything being red, you have no visibility into anything, things are on fire. And with Komodor, that provides you eventually with some kind of a health score that helps you understand where to put your focus on, what's the situation in each one of those areas or workspaces or environments, and what you need to do exactly. This is where you should be with Komodor. So helping you solve everything, all the Kubernetes day two operations and day two issues also, that eventually gets to proper health score. And I think this is time for a demo.
Cool. So just let's recap before we go into the actual product. So what you just showed us is a diagram of the analysis flow at Komodor. And we saw that although health management is the core pillar of the product, there's also value around user access management and cost optimization, RBAC, etc. And you raised an interesting point there when you showed the brain and all the correlation engine and all those sophisticated things. It's still only as good as the Kubernetes knowledge that it's operating on, and our product has a lot of expertise baked into it. So it's not just doing all that correlation and analysis, it's doing so in the context of at least a decade of Kubernetes experience, like multiplied by how many ever engineers we have working on the product.
Exactly.
And also another interesting point is that you only improve what you measure. So having that health score is like a good compass for improving your overall reliability. Then you can say I was at point A, then thanks to Komodor, I'm able to reach a much higher health score.
Agree. This is like a really good tool to analyze where you are versus what and how much you can improve. And also one of the tools that can help you decide on whether or not you want to invest in improving some environment or some cluster or workload. So definitely, I agree.
Exactly. So I think everyone's already excited to see the actual product in action and see how all of the things that we talked about come into play in real life.
Great. So let me share the right screen now. Okay, so this is basically the Komodor platform. the main screen of it is the cluster screen, where you can see all of the clusters that are running and attached to Komodor. Here you can also see that you have the workspaces. This is how we call this area. So the workspaces that you're allowed to see. And in each one of those workspaces, you're able to see only the things that are relevant for you. You can, of course, create those workspaces and manage them. But within each one of them, you will only get what you are permitted to see and what you also want to see. And again, this really helps with the focus. So as I said, in this list, you can see all the clusters that are connected. If we dive into one of them, so for example, here, the production cluster, you can see how many nodes are running on it, how many pods you have, the allocation of them, as well as what is the overall health of the cluster. So you have the issues and risk of the workloads, and you have the same thing for the infrastructure, as well as some kind of measurement or understanding of this score, let's call it. So you know how healthy you are in terms of reliability, as well as in terms of cost. And if we dive into that, we get to an overview view, which is basically supposed to tell you what's going on at this moment, and is meant mostly for the DevOps team, let's call it, to understand the bigger picture of things. So not diving into specific issues, but understanding the overall health that, again, helps you in understanding what should be your next step when improving the health of your clusters. So you can see here both real-time issues as well as reliability risks for both the workload and the infrastructure. You can see the health of the Kubernetes add-ons, so things like self-manager, external DNS, node autoscalers, etc. And you can see how many issues each one of them have, and you can, of course, dive in from that point. And you have the cost optimization part, which shows you exactly what is the cost that you're paying today, what is the potential savings that you can have if you embrace the Komodor recommendations. And it can basically help you save money and take action. And you also have, of course, the inventory, the usage, all the metrics of the nodes and pods and jobs and services that are running in your clusters. So let's take, because we're talking about Kubernetes health, let's take, for example, one of the issues here. So I'm diving into the workload health area, where we can see, again, this differentiation between the real-time issues and the reliability risks. So the real-time issues, if you remember, this is when your house is on fires. It's something that it's an issue that requires you to take action. So if we go into this issue, we see that we have a service called event puller service. It's of type deployment, and you can see that there are availability issues that are happening at this time. So going into the unhealthy area here shows us what Komodor can offer. So you can see that you have 0 replicas available of that service. You can see that the issue is going on for the last 5 hours. And you can see that Komodor already processed and understood all the correlations that need to happen in the background in order to provide the root cause analysis and what happened here exactly. So in this case, we see that changes that were done to the API rate limit are causing basically a crash loop backoff. We're getting the evidence from the logs that is showing exactly that, letting you know what was before, what happened after the change, and once you have all that information, you know exactly what to do, you know exactly where to go to. And again, this combines all the information that Komodor has, whether it's historical information of changes that were done, whether it's the GitHub integration that allows us to see exactly the sources that were changed, as well as our AI that takes all that information and digests it into an actual action that you can do and change in order to fix the issue.
And also, it's telling you who to blame, because you can see that problematic PR, and we don't know what happened and why and how to fix it. We also know who to ping on Slack in a public channel.
And it's always nice to blame someone else and not seeing your name here. So make sure
Absolutely.
that. So if I go back to the workload health, we also have the reliability risks here. So what we have here is basically a division to categories. So you have things like cascading issues. This means that a few issues happened at the same time. So if we were talking about the real-time issues, here it's talking again about the real-time issues, but aggregating them into a whole incident, let's call it. You have degraded service risks. So things like not services that are not configured properly, containers that are throttled, recurring container restarts, and HPA reaching the limit. So if we dive into one of those things, for example, the failure, we can see that we had an issue, and that issue caused basically multiple issues to happen at the same time. So again, our AI mechanism behind the scenes evaluated the situation, took all those different services that had this availability issue, and combined them together, investigated them together, understood that the reason is the same, and it could group them under the same umbrella into a single issue of those impacted workloads. So again, you can see the relevant errors, you can see the relevant availability issues, and again, you know exactly what to do because we're again suggesting what happened and suggesting how to do the rollback. So we dived into the workload health. Let's see maybe an example from the infrastructure health. So here again, the same division for real-time issues versus reliability ones. Under the failed infrastructure, you can see node issues, and they explain exactly which pods within those nodes were impacted. You have a node pressure reliability risks that show you noisy neighbor incidents that basically cause different pods or different services to be affected by someone who is performing as a noisy neighbor. And you also have the add-ons issues, so things like auto things like certificate expirations, etc. And one of the most important things, I think, is the cluster upgrades. So today there is really little visibility into clusters that are reaching the end of life, and we know how important it is to upgrade the Kubernetes versions just to keep security up to date and to basically keep everything up to date in terms of backward support and new things that are coming up. So things like seeing how much time you have until this Kubernetes version is about to be end of life, seeing which APIs are removed exactly, and what was changed within them. If we go back to here to this noisy neighbor, so we dive into that. We see exactly which availability issues were caused by this service. We see exactly on a specific node which pods were running and what was the consumption of CPU and memory of each one. So we know who is the problematic service and who is the problematic pod. And this way we can go directly to it, avoid complex investigation. Komodor does everything for you in the background, analyzes all the pods that are running on all the nodes and understanding the usage of each one of them. And this way you save yourself a lot of time, b, a lot of money, since it can cause a lot of waste. And basically you can fix those cases of noisy neighbor again using Komodor.
Yeah, so it started as a misconfiguration. Someone forgot to set the right request and limits for this workload, and then it started impacting other pods, which caused them to get evicted, and then it caused node pressure as well. So we have something like a static configuration doing this domino effect that's affecting the node down the line.
Correct. Exactly. Yeah.
And if you just look at the symptoms of it, you would have no idea. Like you would see pods getting evicted, but it won't be immediately obvious that it's happening because another pod on the same node is hogging all the resources, right?
Correct. Yeah.
Cool. And can you also set the correct requests and limits from Komodor, or do I have to go back to my terminal and write
Of course, you can do that directly from here. You can go to the service itself. You can set up the resources that you're allocating for each one, and you can do it from here immediately.
Cool. Okay, so we talked about Cert Manager and external DNS previously. You showed us an example of what it looks like in real life and how time-consuming it is. How would we go about it using Komodor? Same use case.
Yeah, so as you remember, we did talk about the Cert Manager incident that we showed. And here in Komodor, we have this integration with add-ons. So we have things like node autoscalers, external DNS, and also Cert Manager. So if the same thing happened with Komodor, the investigation would have been like 5 minutes instead of 2 hours of 2 people. So you have this Cert Manager view dashboard that basically shows you everything around Cert Manager. So you can see the status of each certificate. You can see how many of them fail to renew. You can see how many of them are about to expire, so you can take action in advance. You can see how many of them are already expiring. And you can, of course, dive into each one of them, see all the connections and the links between things. You can know on which Cert Manager this certificate is really applying on which services, and you can take action based on that. And of course, also here you have the Claudia root cause analysis that tells you exactly why the certificate failed and couldn't renew. So in this case, let's take a closer look. So yeah, it's almost the same situation that was there, since it's really a very relevant and very common use case. So also here, the relevant DNS record was missing. So we give you exactly what are the actions that you need to do, and you need to go to the DNS server and add to it the relevant record in order to fix the issue. So doing this through Komodor took like 5 minutes, and changing this would be another, let's say, a minute. So total of 6 minutes, and you have your solution right here, and you don't need to do anything else except for that.
And another cool thing is that unlike the previous example, which started when one of the services was already failing, here we know 4 days in advance that the certificate is about to be expired and that Cert Manager won't be able to renew it in time. And we can see the services that are impacted downstream if we don't do anything.
Right.
Without Komodor, you would probably only find out when one of those downstream services will fail. Maybe it will come first from the end users and not the developers who own those services. And then you will have to do that investigation flow that you showed us earlier. So
Exactly that. Yeah. Yeah. Since there is no visibility really into those tools, those add-ons, you don't really know that in advance. You don't know any of this in advance. So yeah, so the only point where you discover things are broken is that they're already broken. And most of the times it's your customers that are raising those issues. And it's a shame to hurt the user experience when you can just do things in advance, be proactive, understand why things are happening, and fix them before they impact your customers.
that's right. So, okay, before we want to leave some room for questions. So before we do that, can you give us a summary of everything that was discussed today?
So we talked a lot about Kubernetes health. So we talked about what Kubernetes health means, what are the challenges when it comes to Kubernetes, how Kubernetes looks like in terms of how it's built and what we need to do to understand where issues come from and do all those correlations. And once you do those correlations, you can't really know where issues will come from, and everything is very complex and hard. And then we started diving into actual solutions, and one of them is indeed Komodor, that shows you exactly what is your health status when we're talking about Kubernetes health, how you can address things in a very timely manner, and basically to use Komodor in order to do this cycle of detecting, remediating, and optimizing, and of course getting the correct root cause analysis in case of issues. And we also talked about the fact that Komodor is not only a reliability and health management tool, but also an entire platform that takes you throughout the entire Kubernetes journey, from the user management, through cost optimization, through the actual fixing of things and controlling the clusters. So I think that's it.
Let's take a 10-second break and come back for questions.